Hey, this is Mike of Black Cat Amplification. We're going to turn this cool old retro radio into a very cool guitar practice amp. Stick around. Okay, so this is one of the most requested videos I have from a lot of my friends. They kind of want to see what's this process of building an amplifier and what are the kinds of things you have to put into it. What kind of tools do I need? What kind of knowledge do I need? I'm not going to go into mega detail on theory and circuit design and things like that. I do have to say, if you've never watched any safety videos on working on amps, do that now before attempting any of the stuff I'm going to show in this video, because it is very dangerous. And even a guitar amplifier unplugged can hold a charge. The capacitors inside of an amp could hold hundreds of volts. And if you touch it the wrong way, it could stop your heart. So please watch as many safety videos out there as possible before attempting anything. So on to the fun stuff, all right? So I build a lot of amplifiers. I build amplifiers, I've done them from kits, I've made my own kits, I've done big head versions, combo amps, all kinds of stuff. But one of my specialties has always been building things in old antique pieces, repurposing an old item. I guess I got a lot of inspiration from Terry Dayton of DLab Electronics. Terry's got a channel on YouTube that I watch all the time, and I've learned a lot of great stuff over the years from Terry. The amp that I'm going to be building today in this thing is actually one of Terry's designs. I've built probably at least 4 or 5 of these. It's just such a great circuit, very simple build. The parts are relatively inexpensive compared to, you know, a lot of larger guitar amps that have a lot more parts, but it's just a great amp with a volume and a tone knob. Actually, Terry's doesn't have a tone knob, so I'm going to show you how I add a tone knob to this circuit, very similar to what you might do in a Fender Champ, right? So the audience for this video is really anybody. I mean, you could, if you're interested in what it is I'm doing, I know it's going to be a long video, but you can kind of see the decisions I have to make from sort of a 10,000 foot level, right? I can't go into too much detail on why I chose this particular thing over this thing and what makes more sense. I may add a little bit of those tips and tricks, but really this is just more about putting something together with a relatively low amount of parts in a quick period of time and have something that's functional and useful and really fun. And the other thing is you're repurposing something that's vintage, right? So you could build this in anything. You could build it in a cake pan, right? I've seen people build amps out of shoe boxes. I've even built them out of little cardboard boxes to prototype little pedals and stuff like that. So this thing is really cool because it has 2 knobs, and it's an old Philco radio, nice bakelite. Everything was in good shape. I got this, I think, off of eBay. There was no electronics inside. The old chassis is in there. And there was some junk on it, but I took that off, and I've actually decided not to use this chassis. I'm going to use my own custom chassis and show you how I put that together. All right, video. Okay, step number 1. Step number 1 really is choosing which amp you want to build and which enclosure you want to build it into, right? Do you want to fabricate your own out of aluminum or steel? Different things. Again, we're going to use this radio for this build. It's already, you know, a unit that I could actually do stuff with. It actually already has 2 holes drilled there that we can use for the knobs, right, for the potentiometers. And I think for this one, I'm going to actually maybe glue in this original radio dial. Sometimes I like to leave a see-through window so you can see the tubes, but I really like the look of this, and it's in pretty good shape. I cleaned it up a bit, and I think I'm going to keep that. I decided on this one I'm not going to use the chassis that's built in here. This is about 1.5 inches by roughly 8 inches. So I decided I'm going to make my own for this. Just because it, you know, I could probably use this. You know, some of the tube sockets could probably even be reused, but there's old solder on there. Sometimes I'll clean this stuff off, but after I started placing parts, you know, just certain things, I was like, you know, this is a little crowded and there's actually a little more space I can use in there. So I'm going to make my own. So you can kind of see how this fits in here, right? So I'm like, okay, I want to build this Raven amp. I need to see what is in that amp. I know it has 3 tubes, and I'm going to show you that next.
But you can see how this actually goes way in there, right? There's probably about 2 inches almost between here and there. I could use that space if I had a bigger chassis. So I'm not going to show this in this particular video, but I have what's called a metal brake, which allows you to bend metal. So I've got this piece of aluminum on Amazon, 12 inches by 12 inches flat, right? So it's a flat piece of aluminum. It's good thickness. It's not super thick, but it's plenty enough for a small build like this to support the weight of the transformers and whatnot and the tubes. So this is probably about a 0.6 or a 0.4 of a millimeter thick, something like that. I'll get the specs later and let you know in the video, but it's a relatively thin piece of aluminum. And what I did was I took basically cut it to the size, you know, I cut it to the width, and I measured this for the length, and I decided it's going to be 1.5 inches high because this one was 1.5 inches high. And what happens is when you put the chassis in there, it kind of butts right up to that window there. So if I ever did want to just use the window, instead of it having the chassis be way higher, it'll actually look nice and flush. So that's why I went with 1.5 inches height. So I took this piece and I have a metal brake which allows me to bend this metal straight, right? So this is a piece of aluminum. You put the metal into the brake and then you lift the brake up and it bends the sides, right? So I'm just doing the 45-degree angles. So it's basically just like a C shape if you look at it this way, right? Now I also had this 1.5 inch by about a 1/4 inch piece of wood laying around. I just put that there for extra stability, and it's also going to give me something to screw the chassis to the actual bakelite. Bakelite's kind of fragile, right? It can crack. So what I'm going to do is I'm going to drill some holes. I'm going to drill some holes on the bottom here and screw the chassis down because it has a piece of wood that I can actually screw to. So that's how I'm going to mount it in there. It's not going to be super heavy, so that should be okay. And probably put 2 screws on each side. So that's why I did that. Another thing is you're noticing, why didn't he put the piece of wood all the way to the edge? Well, the reason is I noticed how close these holes are to the edge of this, you know, to the side of the bakelite, right? So I need to have room for a potentiometer to sit in there. And this is probably one that I'm going to use, right? And you can see it has a really big area on the back end, and that's actually going to be our power switch. So I'll show you how that all works. But see how if I mount it here, it needs to be pretty close to the edge. If I mount it here and the pot shaft is sticking straight out, I need some room behind it. So I could not put the piece of wood all the way across because it would be in the way of the pot. So I have a little bit of clearance there and enough room. So this still provides the stability. It's screwed in on the ends and on the top, right? And then I'm going to actually screw this down on the bottom so that it'll be even more secure part. Okay, this next section is going to be talking about the amp itself. We've already got a schematic, right, from Terry of DLab. This is he calls this the Raven amp. There's 3 tubes. It's about a 3-watt amp. What I need to do is kind of look at this a little bit and see, okay, what are the tubes? What are the some of the kind of bigger parts? Is this thing going to be able to fit in here, right? I don't even know if this particular amp design is going to fit. So I need to kind of have some things ahead of time. I need to have the power transformer, the output transformer, and maybe just the tube sockets, and kind of just place some things to see, am I going to have enough room to work with here? Okay, so let's look at this and see what this means, right? I'm not going to go into, there's so many different types of schematics and different symbols for schematics. Some companies use this little fork, and some companies use a little upside down triangle. There's not a lot of standards when it comes to these amp schematics, but I'm going to show you from this basic one what things mean. So wherever you see a circle here, that's basically a tube, right? Sometimes you'll see a half a circle and another half of a circle because some tubes have 2 triodes, like 12AX7s. You may know 12AX7s from Your guitar amp says the preamp tube, right? That's a 9-pin tube. This actually has 2 sections in it, 2 triodes. So you might see a 12AX7 drawn with 2 halves, okay? But it's just 1 tube. In this particular schematic, it's actually 3 octal tubes. There's a 6SJ7, right? Let me put this up a little. 6SJ7, that's an 8-pin tube, so I have an 8-pin socket. I prefer in almost every build that I do, most of them, to use these built-in sockets. They hold the tubes super good. It grips the pins really well. I don't have a lot of issues even over a long time with taking tubes in and out and losing tension on the pins. They're really well made tubes. They're maybe, I don't know, $4 or $5 a piece. I guess it depends on where you get them. Don't quote me on that because prices change all the time on these parts. But you'll need 3 of these because the 6SJ7 is our preamp tube. The 6F6 is our power tube, right? So that's actually, yeah, that's the 8-pin tube. And then I need 1 more of those. Here it is, for the rectifier tube, the 6X5. Power transformer. So Terry's got a number here, and I'm not sure, he actually may have been listing this one that I'm actually going to use, C500 160. Yeah, C500 160. What this is this came out of an old police radio. It was, you know, on sale on eBay for maybe 20 bucks, and you get a really nice transformer that works really well for this amp. Now you're like, well, what's the likelihood I'm going to find that same radio with the same transformer? I want to build this amp. Well, I've looked up a comparable Hammond transformer. I use Hammond transformers a lot. They're great. I've never had any issues with them. I think they sound amazing. They're reasonably priced. They're also fairly easy to get right now. Some transformer companies, it's really tough to get transformers. So you can use this Hammond 260A for the power transformer. It's probably going to cost you a little bit more than actually ripping this one out of an old police radio. I'll try to put a link in my video description to what model that was. But it has the same specs as this 260A. So a power transformer has 2 sides to it, right? There's windings. So you have the primary winding side, where we're going to hook up 120 volts from our wall, right, from our power cord, and 0 volts, which is our neutral. Now they also have some other ones down here that we're not going to hook up. But this transformer that I took out of the police radio only has 2 black wires. So that's basically the same as this blue and this brown one at 0 volts. That's for a 120 volt hookup. A 100 volt hookup would be using these bottom ones. We would cap those off and not use them, right? So we're just going to use these 2. In this case, this one only has 2 black wires, so we're going to use that to hook up to our power outlet, right? Then on the other side, the requirement for this amp, and you'll see on Terry's schematic here, you see how he says 400 volts AC, right, on the secondaries. So we know 120 volts is coming in from the wall, right? It's going to go through a fuse, right? And we have a switch where we can, you know, flip it on so that it makes connection and comes on. Goes through the transformer, and it takes 120 volts of AC and converts it to these 2 red wires. They're going to be a red color usually. Not on all transformers, but on these ones. 400 volts AC center tapped. That's what CT means. That means it has another wire coming off of the middle of that that's going to go to ground. That little fork means ground. And what does ground mean? Ground just means the chassis, the actual bare metal, right? So we're going to get into that a little bit more when we start wiring this up. All right, so 400 volts. Now you'll see here on this one, the Hammond, it says 200 volts, 40 milliamps DC. Well, it says 200 down here as well. So the red and the red, you can see they're connected. they're actually total of 400 volts. So he's just saying it's 400 volts with a center tap. And this one here does have a center tap as well. See, 0 volts, ground is 0 volts. So that's always going to get soldered to the chassis, okay? It's a red and yellow color. And let's see what we got as far as the windings on this one we took out of the police radio. We've got the 2 black wires. They're going to get hooked up to our power outlet. We've got the 2 red wires, which is the high voltage. So it's going to be 200 volts AC on this one and 200 volts AC on that one. And the center tap is this red-yellow wire. That's going to go to ground. Okay, and then the only wires left on this one are 2 green wires. Usually, in most tube amps, the green wires, not always, they could be a different color, so you always have to look up the specs for the transformer. But these are usually for the heaters of the tubes, right? That's what makes the filaments heat up and start the electrons moving, right? So we have 2 green wires at 6.3 volts. It doesn't take many volts to heat up those filaments inside, but it does take a pretty good amount of amps. So we're going to look at this amps rating and make sure that it's good for our amp. And I've actually built amps with this. It's 1 amp is fairly low, but it works fine for this circuit. And this one I would imagine is probably about the same specs. I don't have the actual printout for this, but I've used these in these builds and it works great. Terry said you could use them. And I did measure this to make sure that it was 400 volts. And how did I do that? Well, I'm not going to go into detail in this video. I could do that in another video. But you can hook these up to something safe, like say a variac, right? Or a light bulb limiter. This would be the power outlet, right? Then I take a multimeter and put it on one of these leads, these red leads, which is we're expecting about 200 volts, and the neutral, the black, the common wire, where it would normally get grounded, can go to this center tap here because this gets grounded. And then I can measure and see when I apply power, am I getting 200 volts to each of these? And for the green ones, am I getting 6.3 volts? It may vary slightly. Your voltage might not be exactly 120 volts coming out of your wall. It might be 125 or it might be 118. So you may get a slight difference in voltage, and that's okay. In most of these amplifiers, nothing bad's going to happen if it's 4 or 5 volts above or 4 or 5 volts below. Okay, so we've discussed in summary for the power transformer, either you pull this out of one of the Lafayette radios, which I'll try to put in the description, or at least what model that is, or you can more easily, instead of having to find an old model and you don't even know if the power transformer is going to work, but if it does, you can probably get a pretty cheap transformer. But in either case, I don't know what the cost of this is at the moment. It's probably around 50, 60 bucks, I'm guessing. I can't remember exactly on this model, but I've used these in these amps before and they work great. So we have the high voltage, we've got the heater filament wires, and we're coming into the wall with 120 volts, and then it's putting this out on the other side. That's what our amp needs. And looking at Terry's schematic here, you can see that the high voltage windings, which are these 2 red wires, 400 volts total, and the heaters are 6.3 volts, right? And I'll go into how we're going to wire this up. What does this mean when we actually get to it? But all I need to know is, do I have the right power transformer? As long as it's 400 volts center tapped or 200 on each thing, you're good to go. And then you have to have a 6.3 volt for the heaters. Let's move on to the output transformer real quick. This is a very simple one that I use a lot, actually. You can see I have a couple different types of amps that I can actually use this in. So I always note that down if I'm grabbing something real quick, because I've used them in those amps before. So basically, a output transformer has a primary and a secondary, right? So the primary is what comes in and the secondary is what goes out. And you can see up here in the schematic, Terry schematic, up here near the speaker, we have the output transformer. That's usually the last thing that goes out before it gets out to your actual speakers, right? So he's got a number up there, T2 OT-47605. I don't know what that is. That's probably Triad Electronics output transformer or something. In either case, I use a lot of Hammond stuff. What we're really looking for is the primary number. What's the primary that this is looking for? You see how it says 7K there? 7K meaning 7,000. That means 7,000 ohms it's looking for. So that means that the 6F6, because there's just one power tube, that's the power tube, right? That's good. What's going to give us our volume in the 3-watt amp. What this 6F6 is looking for, what would be happy with, is if it's coming in at a 7K primary. Okay, so let's check this. So we bought this 1750AX. One thing when you buy an output transformer is you want to make sure that the wattage value is enough watts. It can be more than the amount of watts, slightly, but not less. Sorry, I was trying to see if the sticker had the watts on there, but actually I think it has it on the transformer itself. 3.5 watts, and this is about a 3-watt amp, so this is a perfect transformer to use. Now, the other reason why it's perfect is because you see it has 7,500 ohms. Well, that's really close to the 7,000 ohms on this side. That 500 is not really going to make much of a difference as far as impedance to the amp. More on that in another video, but this is definitely a good, cheap, but great sounding output transformer that takes up a relatively small amount of real estate. And you see how small this is to power an 8 ohm speaker on that side, right? Or a whole 8 ohm cabinet, right? Or even a full stack if you wire up 2 output jacks, which is what I'm going to be doing on this. As long as you're providing it with 8 ohms, the amp's going to be happy. So that's our output transformer. So you could go on to Hammond's website or other transformer manufacturers, and you want to look for that 7K range. 7,000 to 8,000 ohms probably is good for this 6F6. Now, how do I know with the 6F6 that it's liking this 7,500 or 7K ohms? Well, if you look at the data sheet on a 6F6 tube and you look for the load resistance, see how it says 7,000 with the pentode connection. So that's where that 7,000 ohms comes from. This is 7,500, again, slightly higher, but it's fine for this application. 7K, that's where that's coming from. So because that's power tube is a 6F6, you can look it right up on here and see load resistance equals 7,000. All right, so that's where that tube will be happy. Okay, so we've got an output transformer, power transformer. We've got a general idea of the bigger, larger parts that are going to need to go into this amp, some of them anyway. And we need to know, is it going to fit on our chassis? So laying out the chassis, how do we do that? Well, that's actually a very, very, very important step in all amp building, is laying things out, because depending on where things are, right, you got your power transformer here, so it's upside down right now, but just for ease of letting it sit up. If I put this like this and I build the amp somehow like that versus like this, that can make a huge difference in noise in the amp. Just that little bit, just that tiny little move. That, build it this way versus this way. One of these directions is probably going to create a ton of noise in the amp. So that's a whole nother topic that you can look into. There's tons of videos on the subject. Maybe I'll make one day about layout. But some general rules of thumb is your power transformer, in most of my builds anyway, is going to be on one side, right? I'm just going to pick this side for now, right? It doesn't really matter which side when you have an amp like this, because we're going to be building this without an actual board, right? I'm going to be doing it point-to-point wired. So there's going to be no boards inside this amp. There's going to be a couple terminal strips that we're going to solder some things to, but everything else is going to be connected directly to the pins on the tubes, okay? So basically, do I have enough room? So I'll put these right here. Let's say I have The output transfer, the further away these can be, probably the better, but you can get away with amps where the the output transformer is in the middle. Another thing I might do is actually mount this underneath, because it's so short. I may actually be able to hide it away inside if there's enough room. So let's assume I can't do that though. And I just want to see, am I going to be able to build an amp with this amount of components? Well, for the most part, it doesn't look too bad, right? I've got a little bit of breathing room for the tubes. I've got a power transformer sitting on there. It's got a little bit of room around it. I've got the output transformer. Is there anything else that needs to sit up here? Well, in this particular amp, not really. One thing that could sit up there, it would be like a can type filter cap if we were going to use a can. The filtration for the amp, which really is going to cut out a lot of noise, usually comes after the power section, right? So we talked about power transformer right here. The signal gets rectified through the 6x5 tube or through our diodes, because we're going to have a switch to do either. And then this is really our main filter section. You're going to see this in almost every tube amp. There's going to be filtration or caps, right? Capacitors that are going to be after the rectification stage. So you can see here there's a 47 UF. Let's say you don't even know what that means. No problem. It's just some rating that this capacitor has. The capacitor is usually this two double line symbol with no line connecting them. Sometimes you'll see a plus or a minus, or a plus and a minus, showing you which direction, because some caps are polarized and they actually do have a plus side and a minus side, right? The minus sides are going to ground. These little forks again mean ground. They're going to be tied, they're going to be soldered right to the metal on the chassis. And they kind of go off and they feed different things here after the power gets filtered. They feed this tube and they feed that tube with high voltage, right? So that's what's happening. It's saying rectify it. What does rectification mean? It means it changes your incoming wall signal from AC to DC, which is what your tubes are looking for, right, to power them. So we need to take that AC signal, which is very noisy, and turn it into DC, which is happening here. And then we filter it, right, which is happening here. And then we supply the power to the rest of the tubes in the amp, using that filtered nice high voltage, right? But we have to filter it through these caps. So what a can cap is, and like I said, I'm not going to use one in this particular build, but here's an example of an older one that I tore out of a radio. Modern ones, you know, look very similar as well. But this is one that has 30 MFD, 30 MFD. It means there's two sections here that have 30 UF. 30, that's another rating here. You'll see 47 UF, 22, 10. So this is a filter cap with two sections in it. If I was going to use a filter cap, I'd need to make sure I have room up top to put that in. But in this case, I actually have some smaller caps that are not in the can form. They're just single ones. I'm going to use those because they take up less room, and I'll be able to mount those inside on a terminal strip. So looking at this, do we have enough room? Did we answer that question? Well, sometimes it's kind of hard for me, because, you know, I might think I have enough room, and then I really got to kind of work things out. But after doing them for a while, you kind of start to know, like, is there really going to be enough room when I flip this thing over and I have all my parts? Well, I know that there's going to be some tubes, there's going to be these, the wires are going to go different places. There's going to be two knobs, so two pots up top here. There's a volume and a tone. I'm actually adding the tone, which is not on this schematic, so I'll show you that. And also on the back here, I need to put a couple things. So let's talk about that real quick. Okay, so for the back of the amp here, we're going to need somewhere to plug our amp in, right? So we have, this is an IEC cable. I prefer to use these where, as opposed to actually just drilling a hole and running an actual power cable coming straight out of the amp. I like these for so many reasons. One is, if your power cord gets damaged, you can easily replace it by just ordering another one, and you don't have to rewire anything in your amp. You know, you might take this different places and step on it and things get weird. you could just buy another one for 10 bucks. It's just super easy. I don't know why people don't put these in amps more, but I think more modern amps have them. I actually have been using these IEC power adapters with a built-in fuse, so it's the fuse and this, and I may use one of those in the amp. I just don't have one handy at the second. So we definitely need room for that. We're going to need room for in this amp, we don't have an impedance switch, right? Because we are only using, this is only 8 ohms, right? So if it was 4, 8, and 16 ohms, like you see in some guitar amps, we might need something like an impedance switch, which would look something like this, right? Impedance switch would have one is your signal coming out, but you have like a tap here for 4 ohm, 16 ohm, or sorry, 4 ohm, 8 ohm, 16 ohm. And you could switch your impedances. But this transformer is just a simple one. Again, it's a simple little build. We didn't need to go crazy with the transformer, and it's only got one tap. So I don't need a switch to switch between different ohms, but I do need at least one jack for output, right, to go out to the speaker. In almost every amp I build, if I can, I always put 2 output jacks, because some people have a 12-inch speaker and a 4x12 cabinet, or a two 212 cabinets, and I like to be able to have options and run my amps through more than one cab at a time. It's so easy to add one extra jack to an amp if there's room, so why not do it? That's my theory, right? Because then if you do have multiple speakers, you can have a really, really nice sounding setup, right? So let's say 2 of those. We'll talk more about the types and what these are later, but I also need an input jack, and the input for this I'm not going to put on the front of this radio, because I will show you. We only have, this particular thing, we only have 2 holes, right? And I've already said I'm going to have a main volume, which is going to be our power on and off and master volume, right? And our tone knob. I'm going to add a tone knob. There's really nowhere else on here where I can have an input. Now I could drill a hole in the bakelite and drill a hole in the chassis in the front and add something where I can put my guitar in, you know, maybe have 2 knobs over here and guitar in here. Perfectly fine, I could do that. I just don't want to mess up the aesthetic of this. Plugging into the back is not going to be a big deal, and for wiring purposes, it actually works out really nice. Talk about that layout again real quick. Why did I set it up this way? Again, I'm not going to go into all the theories, but I like to do it this way for noise reduction. Have all your power stuff on 1/3, since this is a 3-tube amp. All your power stuff in this third, your power meaning your rectification, your filtering, your power cord that comes in, the power transformer. You saw all that stuff on here, all the way on this side where the power comes in from the wall, through the transformer, through the rectifier tube, through the filters, and now it goes out to the rest of the amp to do the other stuff. So all of that on one side is great because it keeps a lot of that AC current, which is noisy in amps, on one side, right? Then the power section, the power tube I'm just going to put in the middle here, right? And then our preamp tube here. So the preamp tube is going to be the most sensitive to noise, no matter if you're using a 12AX7 or you're using one of these octal 6SL7s, or sorry, 6SJ7, I think it is. Any preamp tube is going to potentially be a hot spot for noise to get into the amp. And usually what happens where noise comes in is where alternating current coming in from the power side of things is too close to that tube because it has a hum. And if some amps hum, one of the reasons might be that some of this stuff is too close to the input, right? To the input or the first tube. So the input section I'm going to have as far away from the power section as possible, the preamp section, right? My guitar comes in, it gets amplified in the first stage by the preamp tube, and then it goes to be get louder by the power amp tube, and all the rectification power stuff is sending power this way to power these things, right? But all that AC that might still be over that way is far away from this. By this time, the rectifier tube has already turned it into direct current, DC, and it's no longer AC current. So most of the stuff that's coming over here is all direct current, which is not going to induce noise. Okay, so this is sort of a very high level overview of laying out an amp, right? Now I might take this power transformer and just kind of set it in between the two. You really don't want it super close to your input stuff either, because it has to do with the power tube, the 6F6. It's powering that to go out. So what I might do is just sort of set it kind of in the middle, right? I don't want it super close to the power transformer. I don't want it super close to the preamp tube. Somewhere in here is probably good. And the other thing is, when I was talking about this orientation, like this could be super noisy and this might not be at all. The reason is the cores, the magnetic cores in this power transformer can interact with the magnetic cores in the output transformer, inducing noise. So if you offset them, if you put them the same direction where the iron laminates are going, you see how they're going left to right here? And on this power transformer, they're going left to right as well. That will induce noise because it's creating this magnetic electronic interference. Whereas if you offset it and turn it, you disrupt that field, and your amp's going to automatically be a lot quieter, okay? Just for that reason. So I'll probably do something like this. But I think I've answered the question. Do I have enough room? And I think the answer is yes. We'll make it work. I also have a fuse here. I'm going to either need to include it in the IEC or put that on the back. So as long as I have enough room, I can keep things a little bit of room in between. I may have to add a little switch somewhere, but I think we still have enough room on the back to do all of that. So let's get started on the next steps. Okay, next step. Next step is to build yourself a little kit. I've got this really cool cigar box. Smells awesome. The wood inside smells great. If you ever want little things to keep your parts in and stuff, if you ever go past a cigar shop, just ask them if they have any extra boxes, man. They'll give you, most of the time, they'll just give them away to you. So I had this really cool box. Sometimes I use these things, which this one actually had gotten from Mojo Tone, from an amp kit I built. But I put these parts kits together with most of the main parts that I need, not all of them, but you know, and then I label them. So something like that is a nice thing. But you want to get all your parts together for your build. So I've got this little cigar box, plenty enough to sort of kind of keep me organized and put all the parts together. So let me show you what I put together for this. So we have, let's look at the schematic again. We have the 3 tubes. We know we're going to need 3 tube sockets. So again, they're 8-pin tubes. You can look up the tubes online for the data sheet to see how many pins they have, right? That'll tell you what kind of sockets you need. Where do I get these sockets? Generally, I'll get these from like amplifiedparts.com. There's tons of sites that have different tube socket holders, but again, these are the Belton ones, and again, super great quality, worth every penny. The cheap ceramic ones, yeah, you can save some money, but more than likely you're gonna have issues with those down the road, a lot of the cheaper ones. And some of them probably be okay, but get a good quality socket. Again, these are great. I love these. So we need 3 of those because we have 3 octal tubes with 8 pins. We need 2 potentiometers. Again, there's only 1 potentiometer on this schematic. Right after the preamp tube, right, our input signal from the guitar comes in here to the grid of the tube, gets amplified, and then kind of goes through some tone shaping there. But here's the 1 meg pot. This is the potentiometer. This is your volume knob, basically, right? It says gain on there. Sorry if you can't see that. But basically what this means is when you look at a pot, I'm actually going to use, see how it says A1M? I'm using this because it's a long shaft pot, and I kind of need that for the front of this radio. Long shaft pots are kind of hard to find. Some of them, like these, you can get on Amplified Parts. pretty cheap, you know, but they're limited in the values that the pots come in. And this is one that has a power switch on the outside. This is what this extra kind of chunk of stuff is. You can see it differs from a standard pot with no switch on the outside like this, right? But again, it's kind of hard. That's one thing I have to do, is actually have to extend the shaft size to go through the radio, the front of the radio in some cases, because there's so much space between the chassis and the radio. So that makes it very challenging to do these builds, not being able to just have tons of choices of different pots with a longer shaft already. So sometimes I have to do a whole bunch of work to make smaller ones a lot longer to work for that type of radio. In either case, the way this works is when you look at the schematic and you're kind of looking at the back of the pot here, right? So there's where we turn everything. Forget about what's on the back, because that's a power switch. These three little pins here, most pots are going to have these 3 pins. So that's basically what you're looking at right here. This side, this left side, goes to ground right there. The little zigzag thing is a resistor. That means this is a 1 meg resistor. It's a variable resistor, right? Because you could turn the knob from 0 to 1 meg. So that means that this, wherever this goes, is going to get connected to this middle part of the pot, and then the right side of the pot is going to get connected to this little capacitor here, which is then going to connect to some other stuff. So that's kind of how you're seeing this pot. There's no tone knob on this, but I've actually, this is a kind of just a rough sketch of something I added to a Fender 5F1. It's a basic, simple tone knob that kind of goes from deep bassy tones to really bright, chimey tones. And I've kind of added a couple parts here. So I'm going to use the same exact mod for this Raven amp and show you how I wire it in. But that's going to require a 1 meg linear pot. There's 2 different kinds. So we're going to use an audio pot for the volume, which is usually what's done in a lot of applications. And we're going to use a linear pot, which usually has a B, a letter B on it. So B105 means it's a 1 meg pot. Again, that's a whole nother subject, but you just look for 1 meg pot. This is a one, this was an old Radio Shaft pot actually that I was able to score off of eBay. But it is a linear pot, which means when it goes from 0 to 100, it does it evenly throughout the sweep of the turn, right? Whereas the audio one is sort of very slow to go, and then as you get up near the top, it goes really fast to 100. They're still 0 to 100, both of these. They still have the same value, 1 M, 1 meg, right? But for tone, it sounds better because it doesn't give you this perception of when you get to the very end, all of a sudden it got super, super bright. It's a gradual thing, right? So we're going to use those. Either way, I could actually have screwed up and reversed these, and the amp will still sound great. You're still going to get the same thing. It's just going to be how far you turn the pots to get the sound you want is going to be slightly different. So you're not going to break anything if you miswire these, mix these 2 up. One being a linear pot, one being a logarithmic pot, and a audio pot. Okay. 2 pots. I've got 3 Switchcraft jacks. I use Switchcraft jacks a lot. You could use Cliff jacks, or other things. Cliff jacks are the ones that Marshall uses with the plastic parts. I really don't like those for these kinds of builds, just because plastic stuff wears out and can kind of get loose on you, and it's a different way you have to mount it. This is super easy. These are constructed very, very well. Switchcraft is some of the best jacks. And what I get here is basically this mono conductor with the short sort of shaft here. They have one with a longer one. I really don't need that long. But basically, let's take a look at a guitar cable. When you pop this in here in your jack, right? What's happening is, notice this little turn part. This is touching the tip of the cable, right? That's sort of where the signal comes in from the guitar. The rest of this underneath that black little plastic wafer, that's actually an insulator, is neutral. It's common, it's ground, right? So that part's going to go to ground. So you can kind of see that the middle, the ground part, this of the plug is actually touching this little metal base here, which is actually this lug here, because it's, you can see it's part of it, right? So that's definitely touching neutral. And this part is the tip, so that's going to be where the signal comes in, and that's this pin over here on the opposite side of that. What's the middle one? Well, the middle one is this little, in this particular jack, it has a little thing that gets pushed up. You see that little thing? When I take this out, this little thing is actually touching the tip, right? What that's doing is that's grounding, that's the middle lug here. That's grounding it out, so you don't get noise when your amp is on and the volume is up and nothing's plugged into it. Otherwise, if that wasn't there grounding the tip of this, your amp would kind of be going, you know, if it was turned way up. So what happens is when you put your cord in there, it lifts that little thing off of the tip. See that little strip right there in the middle, just in on the inside? Now it's not touching the tip when the cord's in there, and that means your signal is free to flow through to this pin and out to your tube. So that's a basic switchcraft jack with a ground, you know, one of the little ground tabs there, right? So there's another kind that's same exact thing, but without that little ground thing. We're going to use this for the secondary speaker. The one that's connected again to this bass part here, again, that's ground. And then this one that's not connected to the ground, that's connected to the tip here. So that's where your signal comes in. So what we're going to do is we're going to have a main speaker out with this little ground tab, and one without the ground tab. Now, on the output section, you really don't have to have the one with the little ground tab. You could use two of these and that'd be just fine, because you should always have something plugged into your amp. Whether if you power it on, you always have to have a speaker plugged in, right? So it doesn't really matter, but just, I don't know, I'm just kind of anal about the safety of things, and I use the one with the ground for the main speaker. And then once the main speaker is plugged in, then you can plug in an extension speaker. If you tried to plug into the extension speaker, this is going to be grounding out and it won't apply the signal out to your speakers. So you got to know that you're plugged into the right jack. More to come on that later, but those are the two jacks. So the other one is for our guitar input, and again, that's the same exact thing as the three lug one that we're going to use for our main speaker. So these are Switchcraft jacks. And yeah, you can find them pretty easily on amplifiedparts.com or other websites. Sometimes you can find them on Amazon, but I'd be careful making sure that you get the Switchcraft brand, because there's some really, really cheap brands out there, and I don't think they're made as well. These little wafer insulators tend to crack on some of those. They're just very cheaply made. These are super well made, and they have great you know, it comes with the actual washer and the nut too. So you need those. And on the schematic, Terry doesn't have two outputs. He's actually just got it wired directly to a speaker. So I'm going to show you how to hook up those output jacks, okay? Because that's what I'm going to do differently. I want you to be able to use this as a head unit, not as a combo amp, right, where the speaker's built in. And I'm going to have the option to hook up two cabs, okay? Up to two speaker cabs. All right, so what else do we need? Well, let's take a look at our power section again. We've got the power transformer. That's all this. What's this 1N4007? These little triangles with the line on it. These are diodes. That's a symbol for a diode, okay? So diodes are these little, there's all different kinds, but are these little things here. You might see these little black things. And basically what we're looking for is the 1N4007. You can get this kit on Amazon. It's just a assortment of different things. I rarely use other ones. Occasionally I'll use a higher voltage one. But the 1N4007's right there. Sorry if you can't see this very well. There we go. Sorry about that. The 1N4007 1000 volt. There's 20 of those. I've also got another pack of those because I use them so frequently, and I got these off of Amazon too for a couple bucks max. They're pretty cheap. So we need 2 of those. So let's get those out. And basically what it means on the schematic, when you see these diodes, see that little line there? That's where, it might be hard to see this, but there is a line on one side. It's a gray. It's on this top side here. Let me see if I can. Sorry about that. My video cut out for a second. I'm trying to get a picture of the diode here. There we go. So you can sort of see that gray line right there on the top. That's the orientation of how this actually goes. One thing I want to note, and it's very important right here while we're looking at this schematic. A schematic is really an electrical diagram. It kind of shows how the electricity flows through, what gets powered, and what parts get powered and so on, and how the signal of the guitar goes through, right? From the input to the speaker, right? What it is not, and people get this confused, is it's not a layout diagram for an amplifier. It doesn't, you might not lay your amp out exactly like this diagram is, and you probably shouldn't actually in most cases. That's the part that is a little challenging at first, right? As long as you understand that this part is connected to this part and all that kind of stuff, then you can definitely build these things, but you have to kind of construct your own layout, how it's actually going to be put together with solder, and this thing sticks to this thing, sticks to that thing. And in a point-to-point build, which is what we're going to do, we're going to try to kind of do this so that we have the least amount of connections to make, right? If I can connect this one part to ground without something in between, I'm going to do that. That's what point-to-point means. If I can connect one part of this tube to another part of this tube, if I can make that connection through, say, a resistor or a capacitor without a little lug in between, I'm going to try to do that and reduce the number of connections and keep the amount of the signal that the signal has to pass through a lot smaller, which is actually going to make for a quieter, better sounding amp in general. All right, so more on parts. So what else did we choose? And how did I choose them? So we've got the transformers, we've got the diodes, we've got all the tube sockets and everything. Let's go to the main filter section here, right? So let me zoom in. So we have 3 main caps and 2 resistors. These squiggly lines are resistors. These 2 sort of horizontal lines are the caps. Let's look at the caps. These are what are going to do our main filtering. Again, wall comes in, goes to a transformer. Now we got high voltage, right? It gets rectified either through these diodes or through this tube, and then it goes to the filter section. And it's like, we need to filter this up so that the amp can sound good. We need to clean up things, right? If you think of it that way. 47 UF cap. Well, we need it to be 47 UF at 350 volts DC. So I happen to have this cap here, which is 47 UF. It's the same value, right? And it's at 450 volts. Is that okay, or is that not okay? Well, the general rule of thumb for these is, as long as whatever the schematic says the voltage should be, if you go higher than that voltage, that's okay. Because what that means is, if more than 350 volts, for this cap, more than 350 volts is on this cap, it could explode, right? It's not rated to handle more than that. But this one is 450 volts. So it's actually even safer, right? We're expecting there to be about 250 volts by the time it gets to this. So, a 350 volts is definitely enough to cover us, right? But in this case, I happen to have one that was rated at 450. It's perfectly fine. What I don't want to do is put a cap in there that's rated at 250 volts or lower, because it's probably going to explode. All right, and that's what can happen with caps. This happens to be what's called a radial cap, which means it has 2 leads coming out of one end of it, right? And usually the end with the longer lead is the positive and the end with the shorter lead is the negative. But the best way to tell is, you see these little squares? They're actually minus signs, little minus signs going down. That's the negative side, right? They usually always label the negative side and the positive side. So you see the little plus sign here, that end is what you connect to this larger one. The one that goes to ground, which is the negative, is this side with the little negative signs, right? The shorter one. They might not always be, they might be the same exact length. So don't always go by that. Always go by what it says on the cap itself. So I have that one. That one's good. The 22 UF. Oops, that was a 10. I have these really nice F&Ts. I love these F&T caps. They're expensive, but they're worth it. I've never had any issues with them. I think they're just great caps for filtering. So this one is 22 UF. It's the same value required here, and it's at 500 volts. So again, it's 100 volts above what this is recommending us we should have. So we're safe, right? We just don't want it to be lower. The same thing with our last one, which is a 10 UF, 500 volts. This happens to be. The one difference between the voltage ratings is usually the higher the voltage, the bigger, physically bigger the caps are. So sometimes, you know, if you can get away with a lower voltage cap, you might not take up as much room in your amp if you can find one. But these are ones that I always have on hand for a lot of different amps, and I'm going to use them. I didn't have an F&T 47 UF, but I did have, again, this radio cap. Oh, by the way, these are called axial caps because they have a lead coming out of each end. And this end you can see is marked positive clearly on this side. That's the positive side. It also has a little indentation in the can right there where the positive is. So that means this side is definitely negative, right? So the positive, the negative, and on this side, this is the positive. It's just blank because it's showing us that this side is actually negative. Okay, so two different types of caps, perfectly fine to use them. It's just one of them has leads coming out of both ends. This one has leads coming out of this end. It's totally fine. We're going to use it because we have it. Now, let's say I had a bunch of caps, but they weren't exactly these values. Let's say I had a 50 UF cap, right? The voltages we already talked about, but the rating on the cap, that's how much filtering is it actually doing, in a sense. Think of it that way. A lot more I could do on that subject, but let's keep it simple. 50 would be totally fine. Even 30. You can go lower on the filtering, but what generally might happen in your amp is you might get more sag, right? A little bit more sag. It might, if you're familiar with that term, it might not be as sharp of a response when you're playing. If you go lower, like let's say you made this a 33 UF cap, that's fine to do in this type of build. You know, this 22 could possibly be a 16. This 10 could be an 8, right? Something like that, if you had values that are slightly different. In this particular diagram, if you're following the schematic and you want your amp to sound like Terry's here, you want to keep it as close to those values as possible. However, slight differences. If I had a 50 cap, I had a 33 and a 22, your ears are probably not even going to hear that difference, right? But just make sure your voltage rating is enough on the caps. Try to match them to what they are if you can find those parts, right? But they don't have to be exact. And that's one of the things I kind of wished I'd known in the beginning when I started amp building, because sometimes I could have builded some stuff because I had certain parts, but I thought, oh no, I need that exact value. Like I had a 50 UF cap, that would be totally fine there. And you're probably not going to hear any difference at all, right? Because this job is filtering that line to make it clean for the other power, the other stuff, right? All right, so we got those. The other thing notice between the caps is a 2 watt 330 resistor, right? If it doesn't have a K or a letter after it, that means it's just 330 ohms. That's the actual value. So I actually have some 330 ohm metal oxide resistors. And these are 2 watt. I actually bought these, I think, off of Amazon. I believe it was on Amazon. Yeah, so I put in 2 watt, 330 ohm resistors. It was probably a bag of 50 of them for $5 or $6. But I use that value a lot, so I wanted to have those. So 2 watt resistor, it usually means it can handle a little bit more power. And you're in the power section here dealing with a lot of voltage. Metal film is great for heat, right? There's different types of caps out there. I mean, I'm sorry, resistors. And some of those resistors work well with in different situations. You could put a 2 watt carbon film resistor there. It would probably be fine. I prefer in the power section to use metal oxide. They usually look like this dull gray color, right? Almost looks like a cement type material that they're made out of. But I prefer to use either those or cement resistors, which actually look like this. Let me just grab one. So you see these little cement resistors, they actually have filled in with cement, they're wire wound. This one is 5 watts, 500 ohms, right? So we need a 10K, and it doesn't specify the wattage. So general rule of thumb with most amps is if it doesn't specify the wattage, you can probably do half watt. In the power section, I would at least do 1 watt here. If it happens to be a higher wattage rating that you have, use it. It's fine. You know, if you have a 5 watt 330, you can use that as long as you don't go below that, because it's a lot of power here. So he specified this should be at least 2 watts, maybe 3 watts even if you wanted. But I know 2 watts will work just fine. 10K, I'm going to make that at least 1 watt if it's not specified, just because it is the power section. If I have a 2 watt 10K, I'll probably use that there too. It's just a little safer. So I'm going to go look for one of those. I didn't have one of those out, but I need to get that resistor. And what else do I have here? Finish up with the parts. I've got my IEC, that's where we're going to plug the cord into, and I've got a fuse that's found right here. Our IEC would be here, our fuse is here. Again, I may switch this out for a IEC unit that actually has a built-in fuse, but for now I'm keeping them separate till I get to actually drilling stuff. And then these other smaller caps here are ones that I picked out for the tone stack and whatnot, right? So again, with the things with the little horizontal lines are caps. Sometimes they're vertical, the 2 lines. You'll see 0.047 UF. Okay, that means it's a cap. And sometimes what you'll see on these, I have these really nice Sozo caps. You'll see 473K, right? That's really a 0.047. You kind of get used to this stuff. You can look it up on the internet, of course, if you're not sure. That is just another thing for 0.047. If it was 474, then it would be a 0.47, right? But anyway, this just comes from years of doing this. But look for a 0.047 UF cap, and you'll find those on Amplified Parts or Mouser or other parts suppliers. So there's that one. I think there was a 0.02 UF, and that's this one here I've chosen, which is 223K. It's just the number that they use, but it means 0.02 UF. And we've got this 22 UF at 25 volts. Notice how it actually has the voltage rating here. It has to be at least 25 volts. So I've got these Mod brand, these Mod brand, I'm trying to get you to see what it looks like. This is 25 microfarad at 50 volts. And I'm going to use that because it's very close to 22. You're really not going to hear much of a difference, if any at all, in the amp. Just because it has a little bit more microfarads, it's fine. And the fact that it says at least 25 volts here, please, we have 50 volts, so we're covered. Remember, you can always go up in voltage. It just means that if you run more than 25 volts through that, it could blow. In this case, we're a little bit safer because we can go up to 50 volts, and this cap will still stay good, okay? The other part of this is the tone control. So what parts do we need for that? Well, we already talked about this tone pot, which was a 1M, but I also need these parts I have here in purple. Is I need a 500 PF cap, which means picofarad, right? It's a low value, and a 0.0047 UF cap. So those are the only parts I need for that. The instructions here was, there's a lot of red writing, but that's because I was kind of helping somebody out to try to do this, and we were doing this for the 5F1 Fender Champ. But what I was telling him was you could probably remove the input jack here and put the pot there and so on. But the parts you need is the 1 meg pot for this little tone control, 500 picofarad cap, and a 0.0047 cap. So what I've chosen for those are, I have a little 500, it doesn't say PF, but this is a picofarad cap, right? It looks like the little, looks like a little jelly bean. So that's for that one, for the tone control. And also, this is another yellow style Sozo cap, and it's a 472, which means the 0.0047, right? The 2 almost refers to the number of decimals before, the number of zeros before after the decimal place, right? I know that's confusing for a newbie, but 472K means 0.0047 UF, okay? If you're confused about that, again, you can look it up on the internet, how to convert those numbers and what they mean. Now it's confusing, but if you do this a while, these values start to become very common to you because a lot of them are the same. All right, and then so I've got most of the caps I think I need. I also needed something for the power tube here. If you look at the 6F6 power tube, you can see that it's got a there's a cap here, right? That's a capacitor. 100 UF at 63 volts. So it's looking for a 100 UF, and I've actually got this little radio cap that is a 100 UF at 100 volts. So it's actually, again, safe because that said 63 volts, but this is 100 volts. If it goes higher in voltage, that's fine. It's actually, even safer. So I'm going to use this radio cap. I could use an axial cap, it doesn't matter. And it's looking for a 750 ohm 5 watt. Again, if it doesn't have a K after it or a letter, then it means ohm. 750 ohm 5 watt. So I do have one of those in cement resistors. I'll have to look for that. I'll look for that and pull that out, but it looked like one of these cement resistors that I have. It's just, this is the wrong value. This is 500 ohm. I need a little bit more. What this is going to do is this is going to bias this power tube, essentially. We're not going to have a separate bias knob for this amp. It's a very simple build, so we don't need to really adjust the bias. So it's going to be it's going to be set by this resistor, okay, and this capacitor. So that's pretty much it. There's a few other things that we didn't put in our kit here, and that's just some odds and ends resistors. So you see this 240K with the squiggly line, that's a resistor. You see this 1.5K right there, that's a resistor, right? It's connected to a capacitor. And what else? There's some other ones. We talked about that one. I got to get that. That's one of the big ones. We've already got these two resistors. Oh, these 200 ohm resistors, we're going to use those in this particular amp, and I'll show you when to use them and when not to use them. Okay, and now I just told you that there were a few things I didn't put in my kit, and those are those resistors. The reason is just because for me, I buy a lot of my resistors, general resistors, in these kits, right? I've got tons of them. I've got kits for different kinds. This particular one was bought off of Amazon. It was Joe Knows Electronics. I don't think he's making these kits anymore, but I love these kits. It had like, you know, all different values. They're all in order. It's like a catalog of all your different common resistor values. And all the ones in this box are 1 watt resistors, right? Which is going to be a lot of amps. You could use half-watt resistors and that'd be fine. But I typically, in these kinds of builds, I just use 1 watt resistors. They're plenty enough for anything in this particular application. I could go smaller if I wanted, but I just, I use 1 watt resistors a lot in this kind of stuff, right? So the reason why I didn't get these out is I'll get these out as I'm putting things together, because there's only 5 or 6 of them I have to get out. I'll leave them in my nice organized catalog box so that I can just pull them out as needed. This is really it. This is our kit. We're ready to build. Before we actually start fixing parts to the chassis, we need to start drilling holes. We need to measure and drill holes for those parts. And that's really where we're at next.